Okay, let's assume that we have a function like this one, f of t equal 2t plus 3t squared I. If we want to do the integral from 0 to 1 of f of t, then we just do this is equal to the integral from 0 to 1 of 2t dt plus the integral from 0 to 1 of 3t squared dt I, and then we get t squared from 0 to 1 plus t cubed from 0 to 1 I, and then we get a complex numbers. We get the complex number 1 plus I. Then in general, anytime we have a continuous function of this form, we can just compute the integral. The idea of this video is to show this inequality, that the integral from a to b of f of t, which is a complex number, if we take the length of this complex number, is smaller or equal than the integral from a to b of the norm of f of t dt. Notice that this is an integral of a real function, and this is the norm of a complex number. This inequality follows easily if we do Riemann sums and we use the triangular inequality, but the idea is to do a proof without having to go to the Riemann sums. In order to do that, we need the following properties, which are very easy to prove. If we have a complex number, let's say c plus di, and we multiply this complex number with this other complex number. Remember that this is a complex number and this is a complex number. Then the product of these two complex numbers is the same as the integral of this integral. And the proof is straightforward. You just write this function in this form, and then you expand, and then you get the result. Another property that is easy to check is that if you take the real part of this complex number, essentially you are taking the integral of this function, and then you take the real part. This is the same as computing the integral of the real part of f of t dt. This is very easy to prove again. Essentially, you do the integral of u of t here, and it's the same as computing this integral and then taking the real part. And this other property is just a property of integral over real functions. If you have the integral from a to b of the real part of a function f of t dt, this is smaller or equal than the integral from a to b of the norm of f of t dt. And essentially it's because the real number, real of f of t, this is smaller or equal than the square root of the real of f squared plus the imaginary of f squared. This is the norm. And then since this function is smaller or equal than this function, then this integral is smaller or equal than that integral. Okay, now we are ready to do the proof of this. Then let's say proof. Let's call c sub 0 to this complex number. And then we have that the norm of c sub 0 square is just c sub 0 conjugate times c sub 0, but this is c sub 0 conjugate times the integral from a to b of f of t dt, and using this property, this is the integral from a to b of c sub 0 conjugate times f of t dt. Okay, we have this property, and now since this is a real number, then we have that norm of c sub 0 squared is the same as the real part of the norm of c sub 0 squared, and this is equal to the real part of this integral, the integral from a to b of c sub 0 conjugate times f of t dt. And now we use this property, and then we can write this as the integral from a to b of the real part of c sub 0 conjugate times f of t dt. And now we use this inequality. Remember that this inequality is true for any function. We are applying it to the function c sub 0 conjugate times f of t, and then we can say that this is smaller or equal than the integral from a to b of the norm of c sub 0 conjugate times f of t dt. This is a real integral, but the norm of the product is the product of the norms, and this is the integral from a to b of norm of c sub 0 conjugate times the norm of f of t dt, and this is just a norm of c sub 0 conjugate times the integral from a to b of f of t dt. And we have the proof, because essentially this change of inequality tells us that the norm of c sub 0 squared is smaller or equal than the norm of c sub 0. Remember that the norm of c sub 0 and the norm of c sub 0 conjugate is the same, times the integral from a to b of f of t dt. And this is it, because we have that cancelling out the norm of c sub 0, the norm of c sub 0, this part, which is just the norm of the integral from a to b of f of t dt. We know that this is smaller or equal than the integral from a to b of f of t dt. And this is what we wanted to show. Okay, this is it for this video.